Hi, this is Antonius Frentis. In this three-part video tutorial, I'm going to cover the basic concepts of MiceOnABeam, and in the process, show you how straightforward it is to use them to create a script for a secure door in Second Life. In order to best understand the design presented in this series, you should have a basic understanding of LSL variables, functions, and control structures. Please review one of the LSL tutorials listed on the Second Life LSL portal if required. The first thing to do when setting out to design a script is to set down some functional requirements. So this is what we want our door to do. When the door is touched by an authorized avatar, it must open for 10 seconds and then close again. If the door is touched while it's opened, it must immediately close. A note card named Whitelist from the door prim's inventory must be read by the script, and the avatar names listed there, one per line, shall be authorized to use the door. Further, the owner of the prim that contains the door script will always be authorized. Whenever the note card is updated, its information should be reread by the script and the door closed if opened. So let's get started. To create a new MiceOnABeam script model, select New from the File menu, and then assign a new script name. We'll call our script Secure Door. A state editor then opens up, which represents the top-level state of the script, where we'll start our design. Often, the hardest part is when you're just getting started. It's here where you have to take a first stab at how to break down the design requirements into a set of one or more states. Each state represents a point in time where your script is waiting for a specific set of events to happen in Second Life. Each event type can be handled in a different way depending on which state your script is in when the event is received. So for our door script, it would be reasonable to have two states, one to represent when the door is closed, and the other to represent when the door is open. Let's go ahead and create these two states now. First, select the State tool from the toolbar, and then click within the State editor at the location where you want the new state to appear. Now do the same for the second state. The next step is to rename the states to closed and opened respectively. You do that by right-clicking over each state and selecting Edit Name. Now resize the two states. Simply click and drag to form a selection rectangle around the states, and then drag one of the selection points to the right. One thing that is critical for every new script is to identify the starting state. This is done by creating a transition from the initial point to the starting state. To create this transition, select the transition icon in the toolbar and then click and hold the mouse button over the initial point and drag over to the closed state. Whenever an avatar touches the door, the script receives a touch end event. If it's in the closed state when this happens, it must move to the open state and open the door. Similarly, if it's in the open state, the script must return to the closed state and close the door. Note that we want to do something different upon receiving the same event type, depending on whether the door is closed or opened. This is the reason why having two states here is an excellent idea. To specify that the script must respond to the touch end event, you must create a transition for it. Note that transitions must be created for every event that you need to handle. As before, to create a transition, select the transition icon in the toolbar, then click and hold the mouse button over the closed state and drag it over to the open state. You can then reposition the transition by selecting it and dragging its endpoints to the preferred location on each of its respective states. Let's now assign it the touch end event by right-clicking and selecting Edit Properties from its context menu. The Properties editor for a transition allows you to set its name, which by default takes on the name of the event it will handle, in this case the touch end event, a guard condition, which enables or disables the transition, and a transition action, which contains the code you want executed when the transition is taken. Next, create another transition to handle the case when the touch-end event is received while the script is in the open state. Simply follow the same procedure as before. Create the transition and align its endpoints, and set its event by editing its properties. So now we've captured the basic logic of our door. However, it doesn't actually do anything other than move between the two states anytime the door is touched. You need to put in some action code to open and close the door. For convenience, we'll first define a state function called doorman, which will contain the LSL code to open and close the door. A state function is simply a way to package up a group of LSL statements such that the function can be called from anywhere within that state, saving you from having to duplicate the same LSL code in multiple places. To create the doorman function, we need to open a state variables and functions editor. So right-click over the background of the state editor and select Edit State Variables and Functions from the menu. Note that the variables defined for a state can only be accessed by code within that state. Defining variables and functions here at the top state of the model means that they will be global to the entire script. Create the doorman function by simply typing in its name in the State Functions area of the editor. We'll want to indicate to the function whether to open or close the door, and we'll do this by passing a simple integer value as a parameter to the function. Call the parameter open, and it will be set either true or false when the function is called. For example, to open the door, call the function with the parameter set to true. Next, you have to put in the code for the function. First, test the open parameter to see if the door must open or close. We do this by using the LSL if-then-else statement. The automatic code completion makes it easy to enter in the standard LSL control structures and functions. It's also advisable to liberally add comments to your code to add additional clarity as to what it does. In our example, we're going to make the simplest of doors, one that turns transparent when opened and lets the avatar walk right through. We can use MiceOnABeam's built-in LSL actions for this. So position the cursor within the true block of the if statement, and then right-click and select Insert Action, Primitive Set, Set Object Phantom. The LSL Action Configuration Wizard then is opened up. Right-click to set the on value. Next, you set the transparency of the door so that there will be a visible indication that the door can be walked through. To do this, set Insert Action, Looks, Set Visibility. And right-click to set the 50% transparency. To enter the code to close the door, select the same two LSL actions, but configure the actions to set the object back to being solid and its transparency back to being opaque. For different types of doors, such as sliding or swinging, you would simply replace the code that we've entered here in the doorman function. Having finished, click OK on the editor to save our changes. Now you must add in calls to doorman at the appropriate places in our model. Both states and transitions in MiceOnABeam can have action code. In our case, the simplest thing to do is to call the doorman function within the open state. To do this, open up the Properties editor for the open state. Any code entered within the entry action field of a state is automatically executed every time the state is entered. Similarly, exit action code is executed every time the state is exited. In the entry action, add in a call to doorman with the parameter set true so that the door will open. In the exit action, add in a call to doorman with the parameter set false to close the door. Now further, one of our requirements is to automatically close the door if it is still open after 10 seconds. To do that, we need to set up a timer on state entry. So within the entry action, select Insert Action, Control, Start Timer, and set the timeout to 10 seconds. Within the exit action, select Insert Action, Control, Stop Timer. This action is entered in directly as there are no configurable parameters. Click OK when done. When a timer expires in Second Life, the timer event is automatically generated and sent to the script. To handle this event, we need a transition for it. So as before, select the transition icon in the toolbar, and this time click and hold the mouse over the open state and drag back to the closed state. Move its endpoints as desired. Now open the Properties editor for the new transition and assign the timer event. If 10 seconds have elapsed since the door was opened, the timer transition will be taken after first executing the exit action code of the open state. This will close the door and cancel the timer. Followed by the transition action code, if there happen to be any. And finally the entry action code of the closed state, if there happen to be any there as well. Our basic door is now completed. At this point, you should save your model and generate the LSL for your script and test it out in Second Life. Some things to remember. Create a separate state when you need to handle one or more events in a unique or different way from other parts of your script. Don't forget to specify the default state for the script or for any composite state. To handle a particular event that occurs within Second Life, you must create a transition in your model and assign it that event. To enable or disable the handling of an event, assign an expression to the guard condition that evaluates to true or false. To carry out an action when an event occurs, enter it in the transition properties or in a state's entry action or exit action. And finally, a state function can be used to package up a group of LSL statements that can be called from anywhere within the state. We've now reached the end of Part 1 of MiceOnABeam Basics. In Part 2 of this series, we're going to modify the model to read a note card of avatar names that will be authorized to use the door. Thanks for watching.